Someone's just said something.
But we don't know if it's appropriate to give him the knife on stage.
Oh, that's fine.
Like a real knife in the pool will be there.
You have it.
It's panel.
What?
You have it.
There was something else.
Okay, you should just like take out the knife and just stab him straight up, not even say anything.
That's what I was thinking. I was thinking just walk up,
Can you
take it out of the basket
Yep.
like that, and then say,
This guy. So this is one. This isn't a big deal, right? Let me remind you about a couple things. Question? No. Okay. Rifle. So we know the rifle shoots this bullet. It's got a certain velocity. It's going to penetrate into a wooden block and come to rest inside the block, right? Okay, but the block is resting on a frictionless surface. So what's the block going to do? It's going to move, right? Because of the conservation of what? Momentum. Yeah. So the momentum of the system initially after. Yeah. The momentum of the system originally, all momentum is contained in the bullet, right? The block is at rest, so it has none. The bullet hits the block, and then they both start moving. Okay. So we can figure out how fast it's going, right?
Yes.
Does that make sense? How fast both of them are going. We want to know what fraction of the combined energy of the bullet and the block is lost during the impact, right? So that's not a big deal. We can figure out the energy. Initially, the block has no energy. It's at rest. All the energy, the energy of the bullet has quite a bit. Afterwards, the bullet is lodged in the block, and their combined masses move very slowly, and so we can calculate that kinetic energy, right?
Yeah.
And all we're really trying to do is just find the ratio of how much is lost, so the difference between the two, to the original amount, which is the kinetic energy of the bullet.
Let's do
Right?
it.
So that's no, well, you guys can do it. That's no big deal.
Wait, no, that
You guys can
doesn't
do that
make
one.
sense to me.
Can you do one equation?
Well, so we know this, right? We know that M, what do I call this? M1 V1. Oh, what was that?
Wow, I like it.
I don't know what I just did.
Oh, I liked
I
it.
thought it was a comma.
It made you like
M1
straighter.
V1 has to equal M2 V2, where one is before.
Do that again.
I don't know how I did it.
Do it. Well, you
Just
said
do it
you said
again.
comma, do it again.
To the text, maybe.
Oh.
Convert to text.
Oh.
MZ.
See, it messed up. It just doesn't know. So one is before, two is after, right? Make sense? So we can find out how fast, we can find out what V2 is, because we know M1, we know M2, we know V1, right? No big deal. And then all we're trying to do is find K1, so it's really just the kinetic energy of the bullet, right? K2 is the kinetic energy of the bullet and the block lodged together, right? Because we know their mass. Okay, what's involved in finding kinetic energy? Just 1/2 mv squared, right?
Yeah.
So we know M1 and we know M2, right? So therefore, after the bullet lodges in the block, we know that the combined mass is just, well, that's M2, isn't it?
Okay.
Right? Thanks.
So we're trying to
Oh.
find V2 and then put it in the 1/2 M V2.
Right, so we gotta find V2, and then we're gonna know everything. Then we know M1, V1, M2, V2, and then K2 is just gonna be 1/2 M2 V2 squared, right?
Yeah.
And that's gonna be, you'll see, it's gonna be a lot lower than 1/2 M1 V1 squared, because V1 is so big. Look how fast it is, right? And V2 is pretty small. Okay? And then you just wanna find out how much, essentially what you're trying to find is delta K over K1. So K2 minus K1 over K1 is all you're doing. How much is lost compared to what we started with, right? And we're going to write it as a positive number, though, right? What fraction of the combined energy of the bullet and block is lost, right? How much went away? Hypothetically, let's just say before the collision, there was 1,000 joules of kinetic energy, and afterwards, there was 250 joules of kinetic energy. Then we lost, what 750 was lost out of 1,000, so we lost 75% of our energy was lost.
So change of K
You can
over
put it in
K1
as a
equals-
decimal or a percent.
So wait, that equation you just wrote down is equals percent?
Well, that's just a fraction, but you just write that either as a decimal, like if we did,
Yeah.
so say we lost 750 joules. We started off with 1,000 joules, well, that's equal to 0.75 or 75%. I want to write it with a percent sign, it's fine.
But what we have to put is 0.750.
Doesn't matter, either way, yeah. 0.75 or 75%, okay?
You have to put three significant digits.
3 significant digits, yeah.
That's not on the assignment though.
No, it's not.
On my
It's on the
assignment.
take-home.
I didn't want to give you another sign, but you had enough, yep.
No, but 11.1. Did we learn 11.1 already?
This would have been,
Oh, we did it, we did it. We did that sort of thing yesterday.
We learned 11.1.
yeah, couple, yeah. So let's look at another one. You tell me, does that gets you going on that one a little bit though, right?
Yeah.
Okay, so now, let's, okay, no big deal. We did look at one like this, right? All this is, let me just remind you a couple things about this. If there's no external forces acting on a system, mechanical energy is conserved, right? So that just means initial kinetic energy plus initial potential energy equals final kinetic energy plus final potential energy, right? Potential energy, though, remember, is completely arbitrary. Where you measure it relative, it's mgh, but how do you measure h? These have to be consistent. We could measure the height from the floor, from the ceiling, from the moon, doesn't matter. As long as you're the same every time, you're going to end up with the same number on each side of the equation, right? So in something like this, if a rider approaches a hill on a level road, and then he's going to coast up the hill, where would you probably set h equal to 0?
The bottom of that hill.
Bottom of the hill, yeah, on the level road, right? Does that make sense? So you're really just solving for h things, starting off at 0 and it's going to end up at some value.
Wait, so how would you?
So you just know m1 1/2 m1 v1 squared plus, well, and m1's, it's not changing, is it? It's just m, let me start over. 1/2 m v1 squared plus mg h1 equals 1/2 m v2 squared plus mg h2, right?
Right.
Okay, all that means is just the combination. Remember, we had that discussion about the ball in the air, remember?
Yes.
And we said we knew the kinetic energy at the start and the end,
Yeah.
how fast it was going to be going at the top. Well, all we knew was at the top, we knew the height, right? And so if we knew how much gravitational potential energy it had, well, then the sum of that plus its kinetic energy had to be the same the whole time, because there were no forces acting on the ball, right? And only gravity's acting on the ball. That's okay. Gravity gives us gravitational potential energy.
So you solve that and transfer?
Yeah, we'd set h1 equal to 0, right? So our initial kinetic, what's our final kinetic energy? 0, right? Because it's coming to rest on the hill, right?
Yeah.
And so we're starting off with some kinetic energy, and it all gets converted into potential energy when we coast up the hill. Okay, make sense? Okay. All right, what else?
Working on test.
Yeah, you can. Yeah, there's one I definitely want to do. You just tell me.
I thought the other class said you did answer like a phonic, right?
Well, I mean, I showed him one. That's the last question I
I
want to
don't
go
know how
through.
to do that one.
What's the,
We would know this.
what's the password for the?
I wasn't here today.
There, for the at-home test, there's none.
No, but I'm not on that.
Oh, the other one is spring. Yeah. Okay, so all this one is really all you're doing here. So yeah, we went through this one yesterday.
Yeah,
This is
yeah.
just if you want to find out how far. I even gave you forces on this one, right? I gave you forces
You
and
didn't
masses.
give it forces on the assignment.
Right, you don't need them because it's the same each time, and so they'll cancel out.
Okay.
Okay.
So
But on, well, you would just say that the change in kinetic energy, right? So 1/2 m v squared, like v prime squared minus v squared, right? Because I can factor out the 1/2 m is equal to FD, force times displacement, right? Times -1 because it's friction.
There's just a lot of velocity.
There are. See, there's two separate, all this really is two separate, you're going to calculate the ratio of how far it takes to slow down from 55 to 32 to how far it takes to slow down from 32 to 9. Okay, that's it. Both of those are, okay. And on this one, because I gave you all the particulars, you don't even have to do anything tricky like writing the ratio and can't. You can literally just solve for how long it takes. If you know what the mass of the car is and what the force is, you could have done this problem honestly like 3 months ago, because this is just involving friction, and you could do this the old-fashioned way if you want to. Okay. Because you could find acceleration if you wanted to, right? F equals ma. So if you know the mass of the car and the force, then you could figure out what the acceleration is. But I wouldn't do it that way.
Yeah, this is
Question number
hard.
4 on the practice 11 assignment. It hurts my head to read it.
Okay, let's look at
Oh,
that.
the dinosaur one? No,
Yeah, the comet.
yeah, the comet. Yeah.
Oh, the comet one is really easy though.
And it's talking about bombs and
And
then
then, yeah, we're
the
talking about
Yucatan Peninsula.
Japan, and then we're talking about dinosaurs, and I was like,
It's all over the place.
But I think I understand.
I thought, I didn't put that one on the test. It's got one answer, but I thought that was a pretty cool question.
It is.
Yeah, but I'm just like, I didn't know if you were being serious.
Oh, I
or if
was.
you're like,
No, it really is. Everything on there is real. Yeah. Okay, so last one. This is the one I want to just briefly have you take a look at. Yeah. It's only worth 6% on the test, so you don't even have to do this one. But I just want you to see how you could. If you choose to do the challenge problem, here's how you would approach it. So,
It's on the test.
it's a 6-point question, so it's worth 6% of your test. So if you didn't do it and you got everything else right, you get a 94 on the test.
Or you could just do it.
Or you could just do it, exactly.
They did on. That's what Nike did. Yeah, you're like Nike.
Yeah, Nike did this problem on their test.
Based on 74.
All right, so this is a good one. So this is, first of all, it's a perfectly elastic collision. That's an important term in physics. It means no kinetic energy is lost. So it's perfectly bouncy. Okay, no energy is lost during the collision. So when no energy is lost, then that gives us two ways to solve for unknowns. We have two equations that apply. We have conservation of momentum, and we have conservation of energy. Right? Momentum is always conserved in any collision. So one thing we know is if we call this M1 and this is M2, right? Then we know that M1 V1 plus M2 V2 would equal M1 V1 prime, right? So after the collision, plus M2 V2 prime. Okay, that's the same thing we've done forever, right? That's just saying that conservation of momentum. Momentum of the system before equals momentum of the system afterwards, right? This is really just the momentum of the first ball plus momentum of the second ball before equals momentum of the first ball plus momentum of the second ball afterwards, right? But now we know energy is also conserved, right? So now we also know that 1/2 M1 V1 squared plus 1/2 M2 V2 squared equals 1/2 M1 V1 prime squared plus 1/2 M2 V2 prime squared. Okay?
Okay, wait.
And in this problem, the only things that they give us everything except the initial and final velocity of the second ball. So the unknowns, the two variables would be V2 and V2 prime, right? So let's just plug those in. Let's call these equations 1 and 2. And let's just plug this stuff in. So equation 1, M1 is 6, right? So we'll just plug in numbers for those. So equation 1 is going to become 6 V1, which is what? 12, right? 6 times 12 plus M2 is 12 times V2, which we don't know. We'll make that red. How about? Because it's a variable. Make those stick out. Equals M1, which is 6, times my final velocity, which is -8.
So you're doing the first equation?
Yep. Plus 12 V2 prime. So there's equation 1 if I plug in all the stuff that I know, right? And we could simplify that. We could, what could we do here? We could divide everything by 12, actually, couldn't we? We could divide each term by 12, and that would just give us 6 plus V2.
Wait, why 12?
Well, just because I want to make it as small as I can. 6 times -8 is -48, divided by 12 is -4 plus V2 prime, right? So there's equation 1. We'll put a box around it.
How did that help us? We chopped two variables.
You're right, but now we have equation 2, right? So we could plug our stuff into equation 2, right? So equation 2 then becomes 1/2 times M1 is 3, agreed? So we get 3 times 12 squared plus 1/2 times M2 is 6 times V2 squared, right? Equals 1/2 times M1 is 3 times -8 squared plus 1/2 times M2 is 6 times V2 prime squared. And so we could make that simpler too. We could divide everything by 12, couldn't we? Or by 6, sorry, by 6. We divide everything by 6, we're going to get, what are we going to get? 72 times 3 is 144, so 216. 216,
How'd you get that?
because I just divided this product by
Okay.
6. Okay.
Well, yeah,
Yeah,
72.
72.
3 times 12 squared divided by 6 is 72.
Oh, I divided by 3. Whoops, I should divide by 6. Yeah, you're right. Whoops.
It's still fresh.
Okay, equals, and then, so if I divide -24 by 6, I just get -4. Whoops, not, but times 8, so it's gonna be, whoops, that's squared, I didn't square it, did I? So 64 times 3, so we could do 64 divided by 2 is 32.
32.
Okay. And then plus V2 prime squared. So there are my 2 equations in my system, right?
Yeah, how did that help us?
So now what?
Okay, so now we've got 2 equations and 2 unknowns. So how do we solve, this is real math, how do we solve, yeah, substitution, right? We're gonna isolate one variable in terms of the other one and substitute. So let's go up and let's rewrite these even one more time. Let's rewrite this first one up here. Let's solve it, how about solve for V2 prime?
Yeah.
So if I solve for V2 prime, don't I just get V2 prime equals 10 plus V2?
Yeah.
So there's my substitution equation, right? Okay, down here we can make this one a little bit simpler. We could combine like terms, so let's subtract 32 from both sides, and we're just gonna get 40 plus V2 V2 squared equals V2 prime squared, but V2 prime is just 10 plus V2, right? Okay, so then we could write this as the quantity 10 plus V2 squared, right? Okay, and so we get 40 plus V2 squared equals the quantity 10 plus V2 squared. Now we have to solve that. So if I FOIL that out, I get 100 plus 20 V2 plus V2 squared equals 40 plus V2 squared. But look what happens to the V2 squared. They cancel. We can subtract those away, right? And so this is easy. Then we get 20 V2 equals negative 60. Everybody agree? So V2 equals negative 3. And all I got to do is plug it back in. So negative 3 plus 10 is 7. So V2 prime equals 7. Now which one does it ask for here? It wants to know the velocity of the second ball prior to the collision. So that's going to be V2. So it's negative 3. Okay? Make sense?
What did we do after that?
So we plugged this in up here because we found what V2 was. Then we go back to our substitution equation to find the value of the other variable, which we didn't really need to do anyway because the question didn't ask for that. The question just asked for the speed of the second ball before the collision, and so that's that one, isn't it?
Okay, so
Right.
the answer would be negative 3 meters per second.
Yep. Yep, so negative 3 meters per second. Now there is, I'll show you a shortcut way to do this on your calculators. There is an easier way to do this one. This is, and you don't have to do it this way. It works out pretty easily the other way. But you can, you gotta go.
I'm gonna come in tomorrow here at 10.
Okay, that works. Okay, so we could go up to y equals, and we could graph all of the functions. So they have to be functions is the thing. That's the problem. Because if we look at these two, here, one away. Would you agree that when I simplify this guy right here, I get, no, hang on. This guy right here, right? So here's my other equation. Let me circle both of these in purple. So here's one equation. Let's call V2 prime y, and let's call V2 x, because our calculator doesn't have V2s on it, right? All it's got are x's and y's. Okay. So this is going to be like our x. This is our x, and that's our y. So we get y squared equals x squared plus 40 is one equation, and y equals x plus 10, right? But look, that's not a function, right? That's going to end up being a hyperbola, is what it's going to end up being. So we'd have to solve this for y. So if I solve this for y, I get two functions. I get y equals plus or minus the square root of x squared plus 40, right? So all I have to do on my calculator then is just go in and graph all of those. So we could graph the square root of positive the square root of x squared plus 40. We could graph negative the square root of x squared plus 40. And we could graph y equals x plus 10. And then let's just go from negative 10 to positive 10 on x, how about? So we'll let our window go from negative 10 to positive 10 and just go zoom 0. Okay, so there's y equals positive the square root of x squared plus 40. That's one lobe of the hyperbola, there's the other, right? And then here's our line, y equals x plus 10. Well, y equals x plus 10. If I were to move this out further, what I'd see is this bottom hyperbola is going to move away away from the line and they're never gonna cross. Okay, so it's only got one solution. The solution is that intersection right there, so I would just go, second calc, intersect, and we wanna do the blue curve, and not that one. Oops, I gotta go back, did the wrong one. So I gotta, okay, it's not gonna have one. So go second calc, now it's gonna think for a while, no sign change, yeah, I got you. Okay, so we'll go graph, see what I did wrong?
Yeah.
You gotta go second calc, intersect. But then I gotta choose the right curve. So there's the first curve, but then I've gotta hit the up arrow or the down arrow to get to the black curve for my second curve.
Yeah.
Okay, and then I hit enter. And now I can just hit enter again, and it finds it. X equals -3, y equals 7. What do you know? Those are our answers, right? Alright, so V2 was -3 and V2 prime was 7. Right?
Yeah.
Okay, so I don't care if you do it that way. Well, I mean, you don't even have to do this one, but if you really want that 100%, you gotta do it. So. All right. Have fun. Do some physics.